Welcome back to Animal Behaviour. At the start of this course, I noted that one of the wonderful things about studying animal behaviour is that there are lots of really interesting questions that we can answer with nothing more than a notebook and a bit of curiosity. But of course, as humans, we're limited in what we can perceive about animal behaviour. Animals do lots of interesting things which, for a variety of reasons, are quite difficult for us to study. In this video, we'll look at what sorts of behaviours are challenging to study, and we'll see how technology is increasingly removing barriers to studying behaviours we previously had no way of understanding. So what sorts of behaviours are difficult for us to study? Well, one of the simplest needs in animal behaviour is to be able to distinguish one individual from another. Now that's easy in some species that have individual markings. So whale flukes are famously variable, and researchers can tell the difference between individuals by taking photographs of their flukes. But in most species, like these wildebeest here, one individual...
In the history business, there is a general agreement that you give the worst lectures on the subjects you know the most about. It's the danger of getting lost in the trees. I'm going to try not to live up to that prediction, but I fear it might be true. The problem of the yeomanry is an inherently political one. It's about the fact that as a class, they constituted not only the social, but the political majority within the slave South. In the 17th century, during Bacon's Rebellion, the problem was the willingness of the white majority to back a challenger to the planters' regime and to ally even with slaves in doing that. By the 19th century, the problem was still about the loyalty of the yeoman majority to slavery and the planter class's interests, but by that point the problem was embedded, but now the problem was embedded in electoral politics as well. And that was a consequence of the extension of the franchise in the early 19th century and the development of what historians usually refer to as Jacksonian democracy or white manhood suffrage. Back in the early 19th century, as we have already seen, Southern states were in fact among the first to extend the vote to all white men. South Carolina did this as early as 1808, and they did it very intentionally.
So let's now discuss about the war on Iraq. The war on Iraq started in year 2003, March 20th, and somehow ended by the year 2009. Although there are several troops, American troops, still staying in Iraq, and the number is very small. But that means that the United States was engaged in the war in Iraq, in the Iraqi theater, for more than 6 years. And this is far longer than American engagement in the Second World War. And as a matter of fact, it is on par or even longer than American engagement in Vietnam. It is very difficult to ascertain the length of military engagement in Vietnam, but I think we can say that American engagement in Iraq is at best the same in Vietnam, and at worst much longer. How did this war get started? The first question, of course, is who wanted this war?
In the last lecture, we explained the basic framework of evolutionary game theory. So the idea of game theory can be applied to biology, where plants, animals, and insects have absolutely no capacity for strategic thought. But even in those instances, the concept of Nash equilibrium is useful. The outcome of evolution, biological evolution, is very much likely to be a Nash equilibrium. So in the last lecture of this week, I'm going to give you an example where insect behavior is well predicted by a Nash equilibrium. So I'm going to explain that fig wasps play a particular Nash equilibrium. Okay, so the basic logic of evolutionary game theory is that the outcome of biological evolution is a Nash equilibrium of a game played by genes. So let's apply this idea to the case of fig wasps. Okay, so this is the picture of fig wasps.